evening, everyone. Welcome back to our session. So, in this particular session, we are going to discuss a project on logistic regression, how logistic regression is implemented on a use case. Right. So, as part of this playlist, we have understood regression algorithms. Okay. As part of supervised learning, we have classification and regression algorithms. And in this playlist, we are understanding the concept of regression algorithms. In the previous sessions, we understood linear regression, how linear regression works, and how linear regression is implemented on a real world use case. Later on, we understood the concept of logistic regression. Then, today, we are going to implement logistic regression on a data set. Okay, so this is the data set on which we are going to implement logistic regression, friends. Okay, so this is related to rain prediction. Okay, so we are going to build a logistic regression model, and this particular model will predict whether it will rain tomorrow or not. So on the following day, is it going to rain or not will be predicted, right? Okay, I hope it's making sense. So, and this is the data set that I'm using, and all of these are the inputs: location, minimum temperature, maximum temperature, rainfall, evaporation, sunshine, okay, wind gust speed, then wind speed at 9 a.m., 3 p.m., humidity at 9 a.m., followed by humidity at 3 p.m. So all of these are different, inputs, different attributes talking about different, you know, features. We have the output column in which it is going to talk about rain. Will it rain tomorrow or not? Okay, so all of these the features. So without no further delay, let's get started. So no, this particular data set contains 4 years of daily weather observations. Okay, and this is from Australian particular location, friends. Okay, from the Australia using open source sites, we got this data set, and the target column is whether it will rain tomorrow or not. Did it rain next day or not? So I'll start the process. Okay. So the first step is we are supposed to import the required libraries. I'm importing pandas for data manipulation. Then pandas profiling for what is the purpose of pandas profiling? Why do we use pandas profiling, friends? Pandas profiling helps us to automate EDA. So I have imported and done. Then Winsorizer, I'm importing Winsorizer from feature underscore engine dot outliers. So Winsorizer helps us to handle outliers. Simple imputer. What is the purpose of simple imputer, friends? Why should we use simple imputer? Simple imputer helps us to do imputation. If there are missing values, if there are null values, we use simple imputer to perform imputation. Done. Okay. Then min max scalar for feature scaling. One hot encoder for performing encoding. To convert categorical data to numeric data, we use one hot encoder. And pickle is a library which is similar to joblib, which is used to save model. Okay, if you want to save your end model and if you want to load it back, you're supposed to use pickle or either pickle or joblib. Okay, then I'm using logistic regression for building the model, train test split for training, you know, we need train data, and to evaluate we need test data. So we are splitting the data using trained less plus function. And in order to evaluate the model that was built, we use confusion metrics and accuracy score to evaluate our model. Okay, the model that we build should be evaluated. So the metrics that I'm considering are confusion metrics and accuracy score. Let me import them. Successfully imported. And also classification report. Along with confusion metrics and accuracy score, I would like to also use classification report to evaluate my model. So done. And finally, warnings. So whenever you import warnings, it helps us to ignore the warnings that you get at the end of each step. Okay, right. And I'm just passing the filter warnings. So this is going to ignore the warnings that you get. Done. So successfully we have imported the libraries one by one and understood the purpose of each and every library. So friends, before you use or import any library, make sure that you are aware of the purpose of that particular library. Why should we import a library? What is the purpose? Okay, what is it available in your working environment or not? How should you import it? All these steps are mandatory, right? Yes. I have imported the libraries. Now I'll start working on the dataset. So my data set is present at this location. Okay. So in my system, I have the location. I got the location, and I'm using it in the function read underscore Excel. Why am I using read underscore Excel? Why not read underscore CSV? Is the data that we have is stored in an Excel file. Okay. So pd dot read underscore Excel is the function, and this will ensure that the data is loaded. It reads the data which is present in this Excel file and loads data into our Python's memory, and it stores in the variable df. So let me do it. Under execution, it's taking time because the dataset size is big compared to the use cases of the things that we have done earlier. So if you see here, the size of the dataset is 52,000 rows and 19 columns, right? So as I have discussed earlier, it is 4 years data, right? The data that we are going to work is of 4 years. So in total we have 52,000 rows and 19 columns. Let me open it. Let us have a quick glance at the data set. You see, so the same data set, in total you'll have 52,000 rows and 19 columns. I think but when you're just going through the data set, you can clearly see that there are null values. In some columns, there are null values. So for that purpose, we have imported simple imputer, right? Yes. Let's continue. What does shape attribute does? What does shape attribute does? Shape returns the dimensions of the data. Shape returns the dimensions of the data. So df dot shape will return both rows and columns. So 52,000 comma 19 will be the output. Okay. Yes. Then I'm using head function to return the top records. By default, it returns 5 rows, the top 5 rows from the data set. Anyhow, even I'm also interested in getting top 5 rows. Okay. So let us get the top 5 rows to understand the data. Probably it is not making sense right now. Yes, I hope it's clear, and you can go through the data. as we have more number of columns, it's 19 columns, right? So it is not able to display all the 19 columns together. Instead of that, it is displaying the full stop, right? So that, for that reason, we have an advantage of using spider. If you just click on the variable, you can quickly access your data set. Yes, so this is an added advantage using spider, and this is not available in all the IDs that we use, right? Then let us use info function on the data, which gives the complete information of our data set. You see, in total 52,000 records, and this 0 to 51,999 are the indexes for each and every record respectively, followed by the data columns. In total, there are 19 columns, and the index for all the columns, column names is given, and the non-null count is also given. So, friends, it is obvious that majority of the columns have null values. You see, min temperature, max temperature, rainfall, evaporation, sunshine. All these columns have null values. Okay, and the data type is float. So there is only two non-numeric columns. One is rain today, and the other one is rain tomorrow. Our Y column is rain tomorrow. Will it rain tomorrow or not? We are going to predict using logistic regression. That is our use case. Right. Now let me get the column names by using columns attribute. So this is going to give the list of column names, all the list of column names, and I'm just removing the unwanted columns from the dataset using drop function. What is the column that I'm removing, friends? I'm removing location column. Axis is equal to 1 represents it is a column, and in place is equals to 2 represents that in place operation should be done. That means within this data set we are supposed to remove location and save the results. Okay, so let me execute. Is it done? Yes, it is done. Previously, the size of the dataset is 19 columns, and after dropping location column, it became 18. Observe. So we are done with the preliminary, things that we are supposed to implement on a dataset. Okay, we understood the information. We understood the size, the columns. Okay, the unwanted columns have been removed. Everything we have done. The next step is performing analysis. EDA has to be done, and I'm performing EDA using pandas profiling. Observe line number 84. I'm performing pandas profiling. I'm using pandas profiling to perform auto EDA. Okay. So for that, I'm taking profile report function where I pass the dataset and give a title, pandas profiling report. It's done, and let me save the results to a HTML file. So it will take time, friends. The reason is we are working on a data set which has 52,000 rows and 18 columns. So it takes at least 2-3 minutes of time, okay, to complete the entire process. So hold on, we'll see. Yes, so it's taking time. Meanwhile, anyhow, we are aware that there are two categorical columns and 16 numeric columns. Yeah, it's almost done. Hold on. The report structure is being generated, rendering the HTML file. And this particular HTML file, yep, it's done. So this particular HTML file will be stored in the current working directory, friends. As I'm using Spider, the advantage of using Spider, you know, is I can get the information of the current working directory in the top right in this box. So for me, this is my current working directory. So I have to navigate to this location where I can find this output. Okay, so let us go to this particular location. So C drive, users is this folder. Under users, we have to navigate to users subfolder, and this is the HTML file where we'll have the complete EDA results. Let us open it. You see, each and every point with respect to statistics. Okay, so how many variables do you have? It's 18. Number of observations, nothing but number of rows, 52,000. Missing cells. So across the data set, it is 1,27,378. So friends, in majority of the columns, there are missing values. It is talking about missing cells, right? So don't assume that we have just 52,000 rows and how it is possible to have 1,27,378 missing values. In a row, it's possible to have 4 or more than 4. You can have n number of missing cells, right? Yes. So this is the count, and this is the percentage. 13.6 percentage of the overall values are gone missing. And do we have any duplicate rows? Yes, there are 3 duplicate rows. Okay, and in total, this is the memory that is getting occupied. And out of 18 variables, 16 are numeric and 2 are boolean. Boolean is talking about rain today and rain tomorrow. And you can also study each and every variable, okay, in detail. You can study each and every variable in detail when you just go through this report. See the distribution, okay. So each and every property can be understood when you go through the report thoroughly. Once after understanding the distribution, you can also go through the interaction plots that we have. Okay, see, this is talking about um, heat map. Okay, correlations. So this is the heat map, and the missing values represented in bars. A count plot is being displayed. To understand the number of missing values present in each and every column. Right. I'll go back. I hope it's not no duplicates. There are duplicates. Duplicates found. Right. So let us start the process of cleaning. Okay. For that, what am I doing? I'm separating X and Y. I'm separating inputs and output from the data set. Okay. So X holds 17 columns and Y will hold only one column. Just observe the data set, and moreover, whenever I'm executing, ensure that you're also having an eye on the variable explorer, because X plus Y should give us DF. So 52,000 rows, 17 columns, and 52,000 rows, it's only talking about one column. Together, you'll get the data frame, original data frame. Then, once after separating these two, inputs and output, what am I doing? I'm separating categorical and numerical features from inputs. Okay, so in the previous sessions that I have conducted on classification and regression algorithms, you know, we are supposed to perform cleaning only on inputs. We should not touch output, friends. Okay, so when you are, as we have started doing cleaning, okay, the data pre-processing, what am I doing? I started separating I started separating categorical features and numerical features from inputs. How am I able to do is there is a function select underscore d types. So I'm just including integer and float values. Okay, if the data type is integer or float, those values, so that will be part of numerical features. And if they have only object data type, they will be belonging to categorical features. Making sense? Yes. Then let us fix the columns. What are the columns do we have under numerical features? All of these, probably all the 16, yes. And categorical features, you'll have only one. That is rain today. Did it rain today or not? Okay. Now, let us go and check how many missing values do we have, okay, in categorical features. As part of inputs, we have both categorical features and numerical features. So let us work on categorical features first. What am I doing? I'm using the logic. Okay, uh, easnel is a function which ensures, which checks whether there is a value or a null value is present in the column, and it sums up the values in that particular column. So the categorical feature rain today has 731 null values out of 52,000. In 52,000 records values, 731 values are missing under rain today column. Okay. Now what am I doing? Let us implement simple imputation. We'll go in this simple imputer and the strategy will be mode most frequent. So I'm initializing simple imputer, then I'll make it to fit and transform on the categorical features, and the output will be converted back to data frame. See, it is only one step that we did in the previous sessions. So in this particular use case, I have divided initializing, then fitting and transforming the result, and finally storing back the results to data frame. Making sense? Yes. Then this categorical feature that we have, I'm using one hot encoder, okay, to encode the values, to convert the non-numeric values to numeric values, okay, and out of the output, okay, in the output, the first column should be dropped. That's what we understood with respect to one hot encoder. Let me initialize and let us apply it on the categorical output. I'm done. And finally, I'll save back the results to a data frame. It's very simple task that we are doing. Okay, so I applied simple imputer on categorical features and imputation is done. And in the same way, I have applied one hot encoder to perform encoding, and one hot encoding is done. So no categorical features as of now. To ensure whether we have missing values in numeric columns or not, let me go and use the same logic, but this time on which columns? I'm going to check them on numeric columns. In inputs, we have separated, right? Numeric and non-numeric. Let us go and check it on numeric columns. See, all of these columns have missing values. Again, before we perform imputation, it's better we go and visualize a box plot. Let us visualize a box plot. Have a look. Oh my god, what is this? Seems like each and every column has outliers, friend. Okay, except one and two, three. So out of 16 numeric columns, only three columns don't have, you know, outliers. But rest of all the columns, 13 columns have outliers. Extreme values are present in rest of all the 13 columns. What you're supposed to do? Use winsorization. Let us go and use winsorization to handle outliers, right? So, but before that, you know, as I'm working on imputation, okay, as I'm working on handling missing values, I'll use simple imputer, and the strategy will be median because we have outliers. Median does not get influenced, right? Even though if you have outliers, median does not get influenced. And what am I doing? I'm applying this particular simple imputer on the numeric columns so that it gets fitted and returns us the transformed results. Is it done? Yes, it is done. Once after having the transformed results, what you are going to do? I'll start converting this transformed results to data frame back. Okay, the mean numeric underscore feet underscore imputed will be converted to data frame. Now you have the data frame stored. The results are converted to a data frame. Let us also go and cross check whether the null values, the missing values are imputed or not. Yes, all of them got imputed, friends. There is no missing value in our data. No missing value. Imputation was done successfully. Now let me go and visualize box plot. Oh my god. Just one column? No. Is it one column? No, not even. Yes, one column. Only one column does not have outliers. So let us go and apply winsorization. Right? So let us initially define our winsorization. I'm defining the function. Okay. The method that I'm using is Gaussian, and I want to treat the outliers at both the ends. The fold that I'll go with is 1.5, and let me pass all the numeric columns. So I'm just initializing the function with the parameters, arguments, done, initialized. Now let me use this function on the columns so that it gets fitted and transforms the results and stores back to numeric underscore features underscore imputed 1. Okay, on this data frame, let us plot a box plot and see whether the outliers got treated or not. No. Did they got treated? In majority of the columns, yes, because I see still outliers in 5 columns. So what does it mean? It means 11 columns, the values in 11 columns, no, they got treated, but in the 5 columns, they haven't. The outliers are still existing. Okay, I see existing the outliers in the output. So in general, what you are supposed to do is you have to change the method and experiment with one more method and execute the same process. So it should be like experimenting. Okay, so you cannot just decide by doing one experiment. But as we are continuing, I'm not doing the experiments. I'm just going ahead. The next step is feature scaling. Yes, Let me use min-max scalar to scale the features. Initialized. Done. Then what is the next step? I'm going to use this min-max scalar on the output that we got from mincerization so that it gets fitted and transformed, and the results will be saved to clean underscore numerical. And getting back this particular clean underscore numerical array to data frame. I'm getting back the results to store to the data frame. Done. What is the final thing? Once after completing all these steps, you know, just go and concatenate the results. See, we have applied the cleaning step separately on numeric columns and non-numeric columns. Once after completing all the cleaning steps, pre-processing steps on both the different types of columns, you have to concatenate, combine the output. So I'm using concat function from pandas. Okay, so this is going to concat scaled df and encoded underscore features underscore df. So the two outputs that we got from the cleaning part, and the final data set will be clean df. Done. Okay, so once after you are done with the final part, what you are doing, you are going to convert your y to, you are reshaping your y. Okay, so into a 2D array. I'm just converting back to a 2D array. So let me do it. Is it done? Yes. So you have done, it's an array. Y reshaped is an array. Now I'll start the actual process, the model building. So I'm using train test split function where I'm passing clean df, which are nothing but our inputs, y, and test size is 20%. So obviously train size will be 80%, and random state that I'm passing is 42. So this will ensure that even though if you run the algorithm for multiple times, you'll get the same output. The output will not change, friends. Okay, let me do it. Is it done? Yep. So this will ensure the data in X train, X test, Y train, Y test. So in train data inputs, in test data inputs, in train data output, and test data output. Then once after splitting the data, what is the next step? The next step is implementing logistic regression algorithm. So I'll initialize logistic regression model first. The model has been initialized. Then this model, I'll go and fit it on the data, train data. So I'll pass both train data, X train and Y train. Done. So logistic regression got trained in the backend. The model got trained. Now, using this model, what am I going to do? I am going to predict on the test data. So I'll be predicting the test data where I am supposed to pass only test data inputs. If you pass test data inputs, you'll get predictions. What predictions? Test predictions is what you get. So let me get the test predictions. Done. Once after you get test predictions, calculate the accuracy score. Okay. How do you calculate the accuracy score? By passing both original test, original output and predicted output. So y test represents our original output and test underscore pred represents your predictions on test data. Okay. So once after doing it, you'll get accuracy, and that accuracy I'm printing. 78% is what I get on test data. Let us also visualize the confusion matrix. Let me print it to the console. You see, so in test data, it is not able to give the best results, but somehow the results are good because it's around 80%, right? The accuracy is around 8. So this is the confusion matrix that you are able to see, and I'll replicate the same on training data set as well. Okay, so as part of line number 196, we are going to get the predictions on train data, and these predictions are captured. We are storing it under train underscore pets. I'll use accuracy score function to get the train accuracy, and I'll print the train accuracy to the console. So train accuracy and test accuracy are almost the same. They are close to each other, 78% and 78%. Right? They're I'm not considering the decimal part, but still, if you consider the decimal part, they are close. They're almost same. And let me get the confusion metrics for train data as well. So this is the data, the metrics that we got for training data set. Yes, it is capturing well, but somehow the results should be, you know, um, enhanced. They should be refined, but we did not do any kind of hyperparameter tuning in logistic regression use case. But in real time, when you are working on any data set and implementing logistic regression, ensure that hyperparameter tuning is also done. Okay, use either grid search CV or randomized search CV to complete your, to just complete of hyperparameter tuning part. But in this particular use case, I did not come up with hyperparameter tuning, but in general hyperparameter tuning has to be done. The main reason is it is going to enhance our output. So don't you know take it for granted. Yes, we have to come up with the best results that are possible. Now I will display the classification report for train data set first. So if you see the recall, it's around 0.77. Somehow the model is good, but not it's not an excellent model, but it's a good model. The model that we have built, vanilla model, is a good model, but it's not excellent. Yes, I'll do the same. I'll get the classification report on test data set as well. The results are same, 7, 8, and then finally storing the model to I'm storing the model so that this model can be used on upcoming data, future data. I hope it's making sense. So friends, what did you understand from this particular session is I'm just implementing crisp MLQ methodology step by step. Okay, so understood the data first. We understood the business problem, understood the data, then followed by we have understood we have imported the data, libraries, then EDA, data pre-processing, and model building, and finally evaluation. Deployment was not covered in my upcoming sessions. Yes, we'll also understand deployment. Okay, uh, but this particular session will ensure the last session for regression classes as well. So if you are not aware of classification and regression algorithms, do watch our playlist. Okay, we have it in our channel. Okay, so whenever you are free, just have a look and learn these important machine learning algorithms that can boost your career. Okay, right. So let me also do this. So finally, my model got saved, and this model I'll use it on my upcoming data. Right. So that's all. It was a great session that we had today. Okay, many of you kept interacting. Good. Yes, if you have any questions, feel free to ask. How can we interpret outliers in box plot? Friend, it's a good question. Whenever you visualize a box plot, beyond the limits, lower limit or upper limit, you find the circles, right? The dots. Those are nothing but outliers, the extreme values. So those extreme values you are treating of. Making sense? That's how you interpret outliers. Yep. Any other questions? Moreover, before you leave, if you feel the session is amazing, just give a like and do share across your connections. Ask them to learn these particular topics as part of machine learning, artificial intelligence. And if you have any kind of questions, post it on the comment box. We'll respond very quickly. Right. So, feedback. Thank you. Thank you so much for joining the session. Yep. That's all for the day. Again, we'll connect in the upcoming session. So in the next session, we are going to plan it on deep learning, generative AI, then computer vision, natural language processing. So we had a lot of fruitful sessions in the upcoming days. So stay tuned, and moreover subscribe to our channel to get all the notifications. So that's all for this particular session. Again, we'll connect in the upcoming sessions. Until then, take care. Have a great day. Signing off. Bye.